Cardiac output. This is the amount of blood that is pumped out of the heart in a minute. This is used to estimate the efficiency of the heart. So it's important clinically, efficiency. And then it reveals how much blood flow your organs are getting. So that's pretty important, right? The tissues of your body need blood. And then we're going to look into the rest of this week, pretty much the factors that affect cardiac output. So cardiac output can be regulated to modulate cardiovascular function. And so cardiac output is dependent on two factors, heart rate and stroke volume. So two different components you already know about. So the abbreviations you'll see for this, cardiac output, CO, equals heart rate times stroke volume. Does this make sense that this is the math? Let's look at it. So, oops, I had that pop up again. So let's just do that. So cardiac output is in milliliters per minute. We are going to take into account heart rate in beats per minute multiplied by stroke volume in milliliters per beat. Remember, this one is our end diastolic volume minus our end systolic volume. And these beats are going to cancel out to give us milliliters per minute. So thereby cardiac output is giving us the number of beats in a minute and the volume in each beat to give us the milliliters, the volume in a minute. So we're going to look at the factors that influence cardiac output, but first we're going to make sure you can calculate cardiac output with an example here. So remember, this is our formula. Cardiac output equals heart rate times stroke volume. What are some normal values for these two things? Heart rate, let's go with a 75 beats per minute. So that would be at rest in a normal individual. Stroke volume, remember we calculated it in the earlier video. Here we're going to go with 70 milliliters per beat. That's a little bit lower than what we saw in that one example. These both are going to vary depending on what you're doing. And that's important. We want to be able to have cardiac output change, and your heart rate changes when you exercise. So does stroke volume. So therefore, so does cardiac output. So this individual, normal resting values, same ones I have right above there, what's their cardiac output? Well, cardiac output equals 75 beats per minute times 70 milliliters per beat. We can cross those out and we're going to get 5,250 milliliters per minute, or 5.25 liters per minute. That's what your heart is pumping at rest. Over 5 liters of blood in a single minute. Pretty cool. We'll get back to this, when you exercise, that can increase by anywhere from 4 to 9 times, depending on your fitness level. 9 times more than that, so like 45 liters per minute. Crazy. So cardiac output, it's a function of stroke volume and heart rate. I'm going to do these in different colors. So each of those things can be regulated and adjusted. So let's do stroke volume first. Stroke volume is determined by the force of contraction, where, right, in the myocardium, the ventricular myocardium. Okay, what determines the force of contraction of the ventricular myocardium? Two things. One is contractility, so the contractility of the myocardium. So this is going to be dependent on calcium levels. We've already reviewed this briefly. We'll look at it again. but you should know that the force of contraction can be regulated by calcium. This is called contractility. The other thing that can determine the force of contraction is the end diastolic volume. So the volume itself actually changes the force. Again, we'll go into all this, look at how this happens. The end diastolic volume is going to depend on venous return. So the volume of blood returning from circulation. And contractility is going to be regulated by our sympathetic nervous system. I'm just going to put this, I'm going to put sympathetic. It's going to affect contractility as well as affect venous return through constriction. Venous constriction. So the two things we'll be looking at is regulation of contractility and regulation of end diastolic volume that both regulate stroke volume. Heart rate can also be regulated. So heart rate is dependent on what? You could do this, right? Depolarization of what? The pacemaker cells, those autorhythmic cells. Depolarization rates can be regulated, right? So we could have a decrease due to parasympathetic. Actually, let me reverse the order, right? That arrow. This could be regulated by the parasympathetic nervous system. Or look, sympathetic nervous system. And I could even go ahead and add in here, this is going to decrease depolarization rate. This is going to increase it. This is going to increase both of these things. So we are going to come back to all these mechanisms, but this is an overview. We're going to look at the regulation of heart rate by altering depolarization rates by the autonomic nervous system. We're going to look at regulation of stroke volume by changing contractility of that myocardium, as well as the volume that is in the ventricle.